Hey everyone, Professor Baldwin here. I was recently asked by one of your classmates how to solve this type of problem. So notice that we have a polynomial and we have some really big numbers. First thing is always to check, do we have a GCF? And we don't. There's no GCF. So we have to deal with these huge numbers. And to do that, you're going to use the key number method. So remember, every quadratic is in the form ax squared plus bx plus c. And the key number says we have two numbers, a times c. So here, 77 times negative 45. So our two numbers have to multiply to this, and they have to add to our b, which is 8. So 77 times negative 45 is negative 3,465. Yeah, super overwhelming because that's a huge number to try to find the two composite numbers for that also add to an 8. So we want to work really smart with this type of problem. We don't want to just randomly pick numbers. So what do we know? Well, first, we know because of the format of this quadratic or this polynomial with a plus and then a minus, it's going to factor out to one positive and one negative. Okay, that helps a little. Now, what else do we know? Well, we know because this big key number ends in a 5, that it's divisible by multiples of 5. So that helps us limit the number of composite values we can use. And then we also know, because this number is so large, negative 3,465, and this number 8 is so small, that our two numbers that add together are actually going to be the large number minus that small number. So that gives us a little less math to have to do. So let's look at the possible factors or composite numbers for negative 3,465. And because we know that we're going to subtract the small number from the large number, we can just concentrate on positive 3,465 and then do the subtraction. So our possible values. Now remember that because it ends with a 5, it's going to be any factor that ends in a 5. So we could have 5 times something that gives us negative 3,465. Well, that would be 5 times 693. And when we add those, or do the large minus the small, that becomes 688, not the 8 that we need. So we know that we need to go much larger. So what if we look at something like 45? Well, 45 times 77 gives us 3,465. But when we add those together, or do 77 minus 45, we get what? 32. 32 is still bigger than 8, but look how far we've come, from 688 to 32. So we know we're going in the right direction. So let's look at 55 next. And you'll see that 55 times 63 gives you 3,465. And then when you do 63 minus 55, yeah, that's our 8. So we have our winner here, 55 and 63. Now remember, these two numbers are telling us how to rewrite that given polynomial, and specifically how to rewrite that middle term. So we're rewriting the 8r with 63 and negative 55. So we have a new polynomial of 77r squared we'll do plus 63r minus 55r, because those two together give us the 8r that we started with, minus 45. And now because we have 4 terms, we'll factor this with grouping. So we group these first two. 77r squared and 63r have a 7r in common. So you factor out 7r and you're left with 11r plus 9. And then our last two terms, negative 55r and negative 45, have a negative 5 in common. And that factors out, leaving 11r plus 9. And then notice that they both have 11r plus 9. We factor that out, and the other binomial is 7r minus 5. So we started with some really big numbers. Just use those clues that you have from the problem. So our key number ended in a 5, so we knew it had to be divisible by some multiple of 5. Just use all the little clues you have and start slowly picking it apart. And you'll eventually get to that factored form. Oh, and a calculator is super helpful when you have these really large numbers.